But why does power matter? Well, it's the measure of the test's ability to correctly reject the null hypothesis. As I mentioned before, power can also be related to type 2 error, and it's related through one's complement. So power is 1 minus the probability of committing a type 2 error. Type 2 error, again, being accepting the null hypothesis, well, failing to reject the null hypothesis when it would be correctly rejected. I shouldn't say accepting the null hypothesis. And type 2 errors occur when a failing condition is accepted as passing. So it's often called the customer's risk because it's the risk that a failing condition is not identified and released to the customer. So the reasons for limiting risk of type 2 error are twofold. Customers want lower risk, and we want controls that effectively identify failures. So this customer's piece kind of has two meanings. It can mean your organization's actual customer. They want to make sure that your capability analysis is valid because you and your customer are determining whether to move forward on this process based on this capability. You need to make sure that that capability is valid. But customer can also refer to you as the engineer. And the supplier would be the statistical package that is providing the service, or at least the test that is providing the result. And you are the customer because you are receiving the result from that test. And the test would be, so you are also the customer too. And as a customer, you want lower risk. You don't want to be accepting data that is failing. So that's why power matters. And different organizations are going to handle the power conclusions a little bit differently, and we'll kind of talk about some ways to do that. But it is really important because it's a measure of how much we can trust our data. So we can use the power to develop testing strategies that minimize that type 2 error. One good way would be to start with the most powerful tests and only use less powerful tests when previous tests identify a failure. This allows us to guarantee the lowest possible risk of a type 2 error. So by starting with a test that has a very high power, if it fails, then we can use a little bit less powerful and keep moving down. That way we always know that we have minimized our type 2 error as much as possible.